Every SAST finding, every DAST finding, almost every breach you've ever read about traces back to a coding decision made by a developer under deadline pressure. Today we're talking about the secure coding practices that prevent the most common, highest impact issues and how to build these habits into a team without slowing everyone down. Let's start with what we might call the big 5 vulnerability patterns and the practical fix for each one. The first is injection, things like SQL injection or command injection. The fix is to use parameterized queries or prepared statements, and to never build queries by concatenating strings together, ever. The second is broken authentication and session management. The fix here is to use established well-tested frameworks and libraries and to never roll your own cryptography or session handling from scratch. The third is sensitive data exposure. The fix is to encrypt sensitive data both at rest and in transit, and to make sure your data classification is clear enough that developers actually know which data is sensitive in the first place. The fourth is broken access control. The fix is to enforce authorization checks on the server side for every request, and to never rely solely on client-side checks, which can always be bypassed. And the fifth is security misconfiguration. The fix is to use secure by default configurations and to remove default accounts and sample code before anything goes to production. Now let's talk about input validation and output encoding, because this is really the universal defense. Almost every injection class vulnerability, SQL injection, cross-site scripting, command injection, XML, external entity attacks all share the same root cause: untrusted input being treated as if it were trusted. The principle is simple to state: validate input at the boundary, defining what's allowed in, and encode output for the context where it's being displayed or used, because HTML, URLs, JavaScript, and SQL all require different encoding. It's also worth understanding the difference between allow listing and deny listing. Allow listing means defining what's valid and rejecting everything else. Deny listing means trying to block everything that's known to be bad. Allow listing is almost always the stronger approach, because you can't possibly anticipate every bad input in advance. Next, let's talk about secrets, credentials, and configuration hygiene. Never hard-code credentials, API keys, or tokens in source code, even in repositories you consider private. Use proper secrets management tools, vaults or cloud-native secret managers, and configuration that's based on environment variables rather than embedded values. Rotate credentials regularly, and especially after an employee leaves the company, or if there's any suspicion that a credential may have been exposed. This connects directly back to the secret scanning capability of SAST tools that we discussed in an earlier episode, and it remains one of the most common and most preventable findings across organizations. Finally, let's talk about how to build secure coding into your team's culture, not just into a document. Secure coding standards should be a living document, tied back to the documentation hierarchy we covered earlier, with concrete, language-specific examples, rather than abstract principles that are hard to apply. Code review checklists should include security-specific questions Not just, does this work? But does this handle untrusted input safely? A security champions program can be incredibly effective, having one developer per team with deeper security training who acts as the first point of contact for security questions on that team. And training should be relevant to your actual code base. Generic annual training tends to be forgettable, but training based on your own recurring SAST findings, here's the pattern we keep seeing in our code, tends to actually stick. To wrap up, secure coding is the cheapest place to fix a vulnerability before it's even committed to the code base. RiskRecap helps translate your recurring SAST and DAST findings into a tailored secure coding standard and training focus for your team, so the same issues stop showing up scan after scan.